Dear learners, in this lecture we are going to study about the test of significance of difference between the two means. This topic of statistics is associated with the inferential statistics, and inferential statistics talks about how we can make the generalization about the population based on our study with the data obtained from the sample. And the inferential statistics, mainly it can be divided into two parts. One is the parametric and another one is the non-parametric. Both type of the statistics have their own assumption based on the distribution of the data in the normal probability curve. If our data is normally distributed in the normal probability curve, in that case we are having every possibility of using the parametric statistics. And if our data is not fulfilling the assumption of the parametric statistics and the distribution of the data into the normal probability curve, in that case we can go for the non-parametric statistics. And basically in this lecture we are going to talk about the test of the significance of difference between the two means. It belongs to the category of the parametric statistics, because here all the tests basically they qualify the all the assumption of the normal probability curve. Now the question rises why there is a need for assessing the difference between the two means. Okay, in psychology sometimes we are interested in knowing about the significance of difference between the population. It means if we are having data from one population and we are having the data from another population, in that case what type of the difference exists between the data of the two populations with respect to certain attributes, certain characteristics, or we can say the certain behavioral attributes. For example, if we are interested to discover whether a 10-year-old boys and the girls differ in their linguistic ability, okay, in this case we have to first randomly select a large sample of boys and girls. Large sample means any group which is having more than subjects, which number is 30, and we try to administer a battery of the verbal test to measure the linguistic ability of the two groups and try to compute the mean scores on the linguistic ability test of the two groups. Here the purpose is to discover the differences between the means of the boys and girls on the scores of the linguistic ability test. Here what we can do is we can have two means, one for the boys and another for the girl, and we try to find the differences between the two means. Okay, if we are having a large difference, in that case we can easily conclude that girls of a 10 years age are significantly more able in terms of the linguistic ability than the 10-year-old boys. On the contrary, if we find the small differences between the two means, then we would conclude that the 10-year-old girls and the boys do not differ significantly in the linguistic ability. Here we can have different variables which may be responsible for this type of the non-significant difference, or the non-significant we can say the mean difference. And all these type of the errors, they may emerge from the different sources. The one may be the sampling fluctuation or the error of the sampling. Whatever difference are obtained in the means, it may be due to this sampling error. And the sampling error is the type of error, it arises from the way we draw the sample from the population and the inherent heterogeneity or the inherent differences within the sample. and it may result into the different type of the mean score and the standard deviation score, even if the sample has been drawn from the same population. For example, even if a population 1 and the mean of the population 2 may be same, but because of the sampling error, and here sampling error is the inherent differences within the sample. For example, if we are comparing the students of the psychology with the student of the sociology, in that case, up to what extent the scores of the psychology students are homogeneous, and up to what extent the scores of the sociology students are homogeneous. Basically on this it will depend that whether we will get the right differences between the mean scores or not. Okay, in order to test the significance of the obtained difference, we must first have the standard error of the difference, and it can be how it can be obtained. Okay, with the help okay, then from the difference between the sample mean and the standard error of the difference, we can say whether the difference is significant or not. But how it can be done? According to Garrett, a difference is called significant when the probability is high and that it cannot be attributed to the chance, okay, that is temporary or accidental, and hence represent a true difference between the population means. It means that if the difference is true, in that case again and again we will get the same result, and the results cannot be attributed to the chance factor or the accidental factor, okay, for which the result may occur. Otherwise, if we are having any type of the temporary or the accidental factor, in that case we may get the result the once or twice, but not again and again at the same time. Okay. Now I will be discussing about some of the fundamental concepts which are associated with the significance of difference between the means, and we all use all these concepts okay, when we compute the t-test or the ANOVA test or the other type of the difference statistics, both for the parametric and both for the non-parametric test. The first fundamental concept is the null hypothesis. Okay, this is very useful tool in testing the significance of difference. It is based on the premises that there is no true difference between the two population means. It means they have the notion that if we are drawing the different samples from the same population, then in that case we should have the same mean and the standard deviation values, but it is not the same because of the inherent heterogeneity within the sample, and because of the different type of the sampling errors, it is very difficult to obtain the same type of the mean and the standard deviation values if we are drawing the sample from the same population. The null hypothesis is a statement of the no difference or the no association and no treatment effect, and the opposite to this we have the alternative hypothesis, and it is a statement of the difference, association or treatment. In the case where we reject the null hypothesis, we are going to accept the alternate hypothesis. If we are rejecting the hypothesis of the no difference, it means there is a difference between the means of the two samples. H0 or the null hypothesis is assumed to be true until proven otherwise, and H1 is the hypothesis the researcher hopes to bolster. It means the researcher starts with the null hypothesis, and once the null hypothesis is rejected, the researcher accepts the alternate hypothesis, which is the ultimate goal of the researcher. And basically, and the statistical hypothesis is not only about the mean differences and about the correlation and are about the ANOVA type of the statistics. Basically it tells you about कि what type of relation is going to exist between the variable, what is the effect of the independent variable and the dependent variable, and many times it can tell you about the direction of relationship between the variable, the type of effect the independent variable is going to have on the dependent variable. In the course of the study or an experiment, the null hypothesis is stated so that it can be tested for the possible rejection. For example, to study the significant difference in the linguistic ability of the 8-year-old girls, boys, we select the random sample of girls and boys and administered a battery of the verbal test and compute the means of the two groups. In this study, the null hypothesis may be stated thus: there exists no significant difference between the linguistic ability of the boys and girls, and if this null hypothesis is rejected, then we can say one group is superior to another group. It means कि if we are rejecting the null hypothesis, in that case we are going to accept the alternative hypothesis, and alternative hypothesis basically talks about the direction of relationship, and it gives you the type of relationship exists between the two means, between the two groups, and it can tell you about which group is superior, which group is inferior, which group is having more significant attribute in comparison to the other group, or the type of behavior attribute, or we can say the psychological characteristic we are trying to measure. And the test of the true difference is basically is known when we accept the alternate hypothesis, and the alternate hypothesis can only be proven when we reject the null hypothesis, and alternate hypothesis can tell you significantly about the true difference between the means. The another fundamental concept which is related with the difference between the two means is the standard error. And standard error is basically, it is associated with the two types of measures. One is the error of sampling and another is the error of measurement. The primary objective of any type of the statistical inference is to make generalization from a sample to some population of which the sample is the part. It means that with the help of the smaller sample, we try to make generalization about the bigger population. It means we try to conduct the study on a small population, and whatever result we get with that sample, we try to make the generalization of the same result about the entire population. For example, if we are doing any type of the test, medical trial of certain type of the medicine, and we are doing that trial on the sample of the 1000 or the 2000 or the 5000 people over the period of the time, and once the effect of the drug has been proven on that sample of the 5000 or the 10,000 of people, and the results has been significantly positive, and after that trials, what we can do is we can make the generalization about the whole population. We can say that if this medical trial has been significant, it has been positive, its effect has been positive on a sample of the 5000 people, and definitely it is going to work for the whole population. So this type of the generalization we try to make about the whole population based on our study with the sample. But while studying the population, we come across the different types of the error which are related with the different methods of the sampling and errors of measurement. Okay, the standard error can be described as the standard deviation of the all standard deviation that have been computed for a given number of samples randomly drawn from same population. It means ki if we are drawing the different samples from the same population, so what type of, what heterogeneity, what internal differences do exist within that sample. And standard deviation is basically, it talks about up to what extent the scores are scattered, up to what extent the scores are scattered. And if we are going to talk about if we are going to talk in terms of the distribution okay, within the normal probability curve, it means that ki in most of the cases our standard deviation should lie around 1 SD plus minus. It means ki around 68% of the score in the normal probability curve, it lies around 1 SD plus minus, or around 68% of the scores, they lie in between 1 SD plus minus. And between 2 SD plus minus, around 95% of the scores lies between 2 SD plus minus. It means ki if we are having the normal type of the data, all the scores within that sample, okay, it should be homogeneous. And if they are not homogeneous, it means that we are having some type of the sampling error, and basically it refers to the high standard deviation values and the high variance values. Okay, the standard error of mean can be calculated by the following formula. A standard error of the mean, or the sigma, is equal to sigma upon under root n, where the sigma is the standard deviation of the sample mean and n is equal to number of cases in the sample. And if the standard error of the measurement is large, it shows the considerable sampling error. It means ki if we are having the high standard deviation means ki scores are not same, or scores are not alike. It means there is a huge, we can say, the dispersion among the scores, and the individuals which they belong to the particular sample, they are not showing the same score, or we can say the approximate score on that attribute. It means ki it shows basically the type of the heterogeneity which exists within the sample scores. For example, suppose a researcher wants to carry out a research on the organizational citizenship behavior of the employees in public sector banks. Okay, since it is not possible to take the whole population, the researcher randomly takes around 1% of the whole population as the sample. Okay, yet another researcher is also carrying out the similar study and also draws 1% from the same population. Thus, if many more researchers were carrying out such a study, then they would also draw 1% sample of the whole population. The problem though occurs when the 1% sample that is drawn by each researcher is different from each researcher, and though each of the 1% sample is the representation of the population, that is the heterogeneous in nature, they are different from each other. The researcher will also compute means and standard deviation for their respective sample, and in such a case it is expected that the means and standard deviation would be same, because the sample has been randomly drawn from the same population. But this is not the reality, because if, for example, if 10 researchers have drawn 1% of the sample from the same population, and their 1% is different from the what other researcher has drawn, it means ki we are going to have the different mean values and the different values of the standard deviation from one sample to another sample. The higher the standard error, the less the likelihood that the sample is representative of the population. Okay, thus the difference between the sample needs to be 0, so as to be sure that they represent the population. What does it mean? It means that ki if the 10 researchers are drawing the 1% sample, okay, from the same population, their representation should be same, their mean values, their standard deviation values and their other parameters of the statistics, they should be same or they should be most approximate, okay, so that we can say that 1% of the sample is truly representing the all the characteristics features of the population, and all the samples, they are not different or they are not heterogeneous. The another very important concept which we come across in statistics and okay, while computing the difference between the means is the degree of freedom, and degree of freedom is basically associated with the number of individuals in the sample or the sample size. And the degree of freedom is a term that statisticians use to describe the degree of independence in the statistical data. A degree of freedom can be thought of as a number of variables that are independent to vary of okay, when we have 1 degree of freedom, there is one variable that can be freely changed without affecting the value for any other variable. And the degree of freedom is basically related with ki up to what extent the variables are independent to vary in a statistical setting. And it is the number of independent observations and the measurements that can be made in order to calculate some statistics such as mean, standard deviation, chi-square, t-statistics. It means ki if we are going for the certain type of the descriptive and inferential statistics, we have to have the degree of freedom. And if we are having the large, if we are having a sample size which is large, in that case the degree of freedom will be high, and there are very possibilities that we are going to reduce the errors related to sampling or the heterogeneity type of the issues within that study. The higher the degree of freedom for any given statistical calculation, the more accurate and reliable it will be, because there are more variables available to account for the possible errors. When a statistics is used to estimate a parameter, the number of degrees of freedom available depends on the restrictions placed upon the observation. 1 degree of freedom is lost for each restriction imposed. For example, if we are having a sample size of the 100, in that case we will have the degree of freedom of the n-1, that is equal to 99 degree of freedom. Okay, why we are reducing the n with -1? It means that if we are doing all the observation for the 100 subjects, the subject number 100 is not having any option or any freedom, but the subject number 99 is having the 2 options, subject number 97 is having the 3 options, subject number 96 is having the 4 options of freedom. So in that case, the degree of freedom basically talks about up to what extent your observations, your parameters and your data can having the independence, or we can say the autonomy to move. And if we are posing the restriction on the sample, it means we are trying to limit that observation. The degree of freedom varies with the nature of the population and restrictions imposed. For example, in the case of the value calculated between the means of the 2 independent variables, we need to compute deviation from the 2 means, and the degree of freedom will be n-1 okay, plus n-2. It means for the different type of the statistics, we try to use the different methods of calculating the degree of freedom. Okay, for example, if we are taking the sample from the from the same population, like 1 sample t-test, in that case the degree of freedom can be n1 plus n2 minus 1. So in the case of the chi-square, we are having different formula for calculating the degree of freedom, that is rho -1 into column -1. So whatever statistics we use, especially for the making inferences, we try to take into account the degree of freedom or the sample size in order to make our results more significant and more viable. The another very important basic concept which which we use in the test of difference is the one-tailed test versus two-tailed test. Okay, one-tailed tests are used when statistically significant difference is predicted to occur, and we are having the another type of the result not with us. When the alternative hypothesis predicts that the end result will be less than what is predicted in the null hypothesis, a left-tailed test would be used. It means कि one-tailed test is basically talks about the single direction of the relationship between the variable. It means that कि if we are very sure about the direction of the outcome of our test results, in that case we are having the option of the two-tailed type of the tests, which are basically they are having the 50-50 possibility of the both type of the results. For example, an appliance manufacturer hypothesizes that the mean lifetime of its electric stoves will last more than 5 years. The phrase "more than" insinuates a change in one direction, which will require a right-tailed test to prove the alternate hypothesis. Okay, for example, the null hypothesis will be like this: the mean lifetime of all the electric stoves is 5 years, and the alternative hypothesis will be the mean lifetime of the electric stoves are more than 5 years. It means कि if we are having with the help of this diagram, I will try to explain that कि in the case of the one-tailed test, we are having one direction of the relationship, and for example, if we are having the probability of the 5%, in the case of the two-tailed test, if we are having the option of the going into both the directions, and the entire probability gets divided into two parts. 2.5% on the right hand and 2.5% on the left hand. A two-tailed hypothesis predicts that the independent variable will have an effect on the dependent variable without specifying the direction to determine if there is a statistically significant difference between the two groups in either direction. It means in the case of the two-tailed hypothesis, the researcher is not very sure about the direction of the outcome, and hence he is of the opinion that his or her results may go in the either direction. And because this test determines if there is a statistically significant difference between the two groups in either direction, it is often referred to as a non-directional hypothesis. It means कि the researcher is not sure of the outcomes and the direction of the outcomes of his or her result. When the results of a two-tailed hypothesis are represented in a bell curve, both sides of the graphic will show a change as opposed to the one-sided significance of the one-tailed test, as I have already shown you in the last slide. Dear learners, in this lecture I have talked about how we can go for the differences between the means of the two samples, and basically I have tried to reach at the conclusion about what are the fundamental principles or the issues which are associated with the differences between the two means, and how we can go for the calculation of the differences between the two means for a parametric type of the statistics. And in this test we have basically talked about what are the conditions for the use of the t-test and the tests of the mean between the two samples and the two population, and we have talked about the null hypothesis, we have talked about the degree of freedom, we have talked about the sampling error, and we have talked about the one tail test and the two tail test. And in this lecture we are going to conclude, and in another lecture we will continue to talk about the fundamentals of the issues which are related with the differences between the two means, and we will be talking about what are the different techniques of calculating the difference between the two means for the parametric statistics. Thank you.